ahead and get yourselves to this section of the notes where it says key concept, how multiple zeros affect a graph. The first paragraph up there is giving you two different polynomial functions that we had from problem number 3. So we had f of x equals x plus 2, x minus 2, x minus 3. That was one of our functions. And then another one was g of x equals x plus 2 quantity squared, x minus 2, x minus 3. X plus 2 quantity squared means that linear factor, that x plus 2, would appear twice. X plus 2 would appear twice because we could rewrite g of x as x plus 2 times x plus 2 and then have the x minus 2 and x minus 3. But instead of writing that all out, we just did the quantity squared. But whenever your linear factor of x plus 2 is repeated, that means the 0 is going to be repeated. X plus 2 gives you a 0 at negative 2. Since negative 2 would appear twice, it's called a multiple 0. So what happens is whenever we have a 0 appearing more than once, in this case twice, negative 2 is said to have a multiplicity of 2 because it would appear twice in this problem. A 0 of multiplicity whatever number means that's how many times it appears. So if you had a 0 of multiplicity 7, that means whatever that 0 is appears 7 times. So if we would say 3, it has a multiplicity of 2, that means the 0 at 3 would appear twice. Now what's neat is going from our multiplicity, we can talk about how the graph is going to act. That's what our key concept says. It's saying if a is a 0 of multiplicity n in the polynomial function y equals p of x, then the behavior of the graph at the x-intercept a, so that's just saying a is our 0, what happens when we're at that x-intercept, if your multiplicity is 1, then it acts as a linear function. If your multiplicity is 2, it acts as a quadratic. If your multiplicity is 3, it acts as a cubic, and so on. So remember, we know linear functions are lines, quadratic functions are parabolas, and cubic functions are what we've been dealing with. That is kind of like a curve and a swerve from negative to positive infinity. So let's make sense of all of these words by doing one of these problems. What are the zeros of our function f of x? What is their multiplicity and how does the graph behave? First, tell me, how do we find zeros of a graph? Last week we were given our polynomials in factored form. Well, now we're given it in polynomial form. Cameron, what do? You have to factor. Yes, you have to factor. Always check for a GCF first. And in this case, we do have one. What's the GCF here? Julius?
X squared.
Good. So factor out x squared. And then look at what's inside the parentheses, x squared minus 2x minus 8. That trinomial can be factored by x minus 4, x plus 2. Once you factor, then you need to find your zeros. What would the zeros be here? Jordan?
-2, 4, and
had 0. Now, I want you to think about from the x squared factor. Yes, our answer is 0. But what happens when you take the square root of a number? You get how many answers? 2, correct? Now, x equals plus or minus 0, well, that's the exact same value. But there are 2 values, x equals 0 and x equals 0. This factor appears twice because it is x squared. It is not just an x, it is x squared. So we need to make sure we account for this appearing twice. Now, if we had just had x times x minus 4 times x plus 2, then we would only have 3 zeros. X equals 0, x equals 4, x equals negative 2. But because that x is squared, we need to account for 0 appearing twice. It is a repeated factor, so we have 2 zeros at 0. Now from here, we can state their multiplicities and talk about how the graph behaves. So I'm just going to make a chart for myself. I'm going to list the 0, and then I'm going to list its multiplicity. And then its behavior. So we have 3 different zeros. 0, 4, and negative 2. Their multiplicity depends on how many times the factor appears in the polynomial. So 0 would have a multiplicity of what? Cameron? 2. Good. 4 has a multiplicity of 1. Good. And negative 2 has a multiplicity of 1. Do you want to grab a piece of paper to take your notes on? Whatever's going to be most helpful for you. Now to talk about their behavior, you just look at the multiplicity and think, okay, if this was a degree of the polynomial, how would it be behaving? If it was a degree 2 polynomial, then I would know that's what, Morgan? A parabola. It would behave as a quadratic. A 0 with multiplicity of 1 behaves as what? Jess? Yes. So that is all the question is asking us to do. But just to make a little more sense of this for you guys, go ahead and switch over to Quick Graph and put in x to the 4th minus 2x cubed minus 8x squared. Put that in so we can look at the graph a little bit. The first one that we just did, x to the 4th minus 2x cubed minus 8x squared. You're going to get something that looks along the lines of this, with our zeros at negative 2, 0, and 4. Now, why I had you guys draw this or sketch it is because now we can talk about, okay, why is this acting linear? Why is this acting quadratic? If it's acting linear, it's acting like a line. So at negative 2, it is crossing the x-axis as a line would. At 0, it's supposed to be acting as a quadratic. Sure enough, it is. At 0, we have a parabola shape. And at the 0 of 4, it's acting again as a linear function, which makes sense because we have it acting as a line going through the 0 of 4. Okay, so that is what we are talking about when we're talking about the behavior. So just by having your zeros and knowing their multiplicity, you could say, at this 0, this is how my graph is behaving. At this 0, this is how it's behaving. You can take the behavior of the graph from its zeros. Let's do another one. What are the zeros of my function? Start by factoring. In this case, we have a GCF of x. Factor completely. Once you do, state your zeros. Who would like to give me the zeros? Jordan, go ahead.
2, 2, and 0.
Yes. So now if I'm going to talk about my zeros, I either have 0 or 2. State their multiplicity. And behavior. What's the multiplicity of 0? Cameron?
1.
What's my multiplicity of 2? Jack?
2.
Right? Multiplicity of 1 has linear behavior. Multiplicity of 2 has quadratic behavior. If we would sketch this, you would get a graph that looks something like this, where we have the graph crossing at 0 and touching at 2. At 0, it acts as a linear function. At 2, it is acting as a quadratic. And that's all there is to multiplicity. We only have one more little thing to talk about as far as section 5.2 goes, and that's our problem number 5, talking about the relative max and min of graphs. Go ahead back to Quick Graph and put in x cubed plus 3x squared minus 24x. You're going to end up with a cubic function that's pretty tall and skinny. You don't have to factor for this. You're identifying the max and the min. So all you're doing right now is putting it into Quick Graph to look at the graph. I'm going to tell you this. Relative max and min occur at turning points. So if I am talking about this turning point up here, What do you guys think? Would we call that a relative maximum or a relative minimum? Jordan?
No.
That's it. This is a relative max. Bless you. Leaving with the bottom one as a relative min. And really the word is minimum. I just always abbreviate it. So minimum, min works the same way. Means the same thing. All you have to do to find these max and mins are zoom in using your graphing tool, zoom in, and look at the ordered pair. Relative maximums and minimums are written as points. Did anyone get the maximum? Jess?
-480.
Very good. And what about the minimum? Just zoom in to your minimum point, read the ordered pair that it's at. Cameron. Very good. That's all there is to it when you're finding relative maxes and mins. I have a question for you. Why do we have the word relative in there? Why isn't this just the maximum and the minimum? Why is the word relative there? Morgan Cowder?
Because those are definite points on the graph.
Yes, because they're definite points. That's a good comment. Morgan Rickley?
Because the graph does go infinitely down and infinitely up. It's just where it curves.
Yes. We have a much, much lower point on this graph because it's going to continue infinitely in a decreasing direction. Same as the other side, it's going to continue infinitely in an increasing direction. But these are two definite points, like our first Morgan said. And so that's why we call them relative max and mins. They're relative because, like our other Morgan said, your graph goes on forever. All right, one more. The got it question number 5. Again, just go to Quick Graph, put your graph in. This one is not going to be at exact points. You're going to need to do some rounding. With rounding, who got a maximum for me? Cameron, what'd you get? Check your graph because your y value should be positive. Did anybody else get a different maximum for me? Jordan?
Well,
Hmm?
2. I don't know what that is between 0.6, 7. I don't know what that is.
I have about 0.8. Negative 0.8.
Yeah, that.
Okay. And then where are we at for our y value? At about 2. Mine's at about 3. Did you guys get 3? Yeah. Check yours, Jordan. It should be about 3.1. And then your minimum should be at about 0.6, negative 2.